Dennis is going to talk to us today about demystifying digital twins. And so this conversation, this presentation came out of a conversation that him and I were having where he was teaching me some stuff. And so I thought might as well kind of extend that out to the group. And Dennis, I'll let you kind of take it away.
As James said, I think for those that don't know me, I've been with Willow, which is a digital twin platform, for a year now. But previous to that, I was kind of more in the fault detection analytics space, working with switch automation. James and I chat frequently. We're both here in Denver. And so I think we were having conversations about what is a digital twin. It was of interest. And so I did my best to condense a lot of those conversations into a few PowerPoint slides. I also snuck in a colleague, Taylor Schmidt, who's also with Willow. He's on the call today to bail me out of any difficult questions on the architecture, kind of just BIM side of this. So a lot of, James, the conversations you and I have had are me channeling my inner Taylor Schmidt. So I figured I should bring him on the call as well. So he's here if we need him today. But I want to start out with this amazing definition of what a digital twin is. Previous to James's Nexus days, he had a little blog. And he wrote this little breakdown of the components you need, I think, to qualify as a digital twin. And I like this. So instead of redefining it, I thought I would just follow his lead. So digital twin needs a three-dimensional model, static data related to the assets, the equipment, streaming data, telemetry data from the systems themselves, a platform for applications, which is kind of this middleware concept, and then analytics and some human interaction. So today I'm going to try to unpackage most of that. I'm going to avoid the computation and human interaction pieces because I think that's specific to the actual platform you buy. But I think everything before that is pretty generic, and we can talk through how you build up what's called a federated model, how you build an asset register, how you connect that thing to live data. And I want to speak a little bit to the data model / middleware concept that helps you feed that data back out to other smart building applications. So first things first, what is a federated model? How do we build it? So this is a real building in New York, and I wanted to start out with this first step that was actually pretty novel to me when I started seeing, I guess, the architecture side of this and the beginnings of the BIM process. A building has to start by being located in space. And so every building that goes through new design where model geometry is coming together needs a project base point, which is kind of a relative point within the model that helps all the different disciplines line up their 3D geometry to a common point. So in this example, the base point of the project is actually on the corner of the project property line for the building. There's this other concept for a survey point, which helps this building kind of locate itself within geospace. So if I have a lat long associated with this building, I actually need to survey and associate this property to where it is in the world. So these two physical points help coordinate all of the 3D geometry that we're about to get into. This concept kind of blew my mind when I first saw it. I know it's pretty basic, but it's kind of interesting to think about this. This also blew my mind when I saw it for the first time. When you design a new building, there can actually be hundreds, if not thousands, of individual 3D models. And so when you talk about BIM, this building information model, it's more about the process of how you coordinate all of these models across all the disciplines that are generating this information. So BIM is much more about the process and not just the 3D element, right? Like the 3D model can be an output of a BIM process, but the most important part of BIM is simply taking all of these disciplines, which really relate to mechanical design and architectural design, making sure they all are working toward a common process. They're all relating to this common base point, most importantly, if you're trying to do something with the 3D geometry. And there's kind of a quality behind this. If the mechanical design is expected to be used for the operations of the building within a digital twin, you need to specify that certain objects do get modeled and that they have the right properties within them so you can use them later on. So this map model actually represents a real project. Each node here, again, is an individual model file. If you were to trace kind of one of these groups, like a cluster, if you will, the mechanical design might be taking models from train for chillers. They can be creating model elements for duct and pipe and pumps and everything else that goes into the mechanical design. Each one of those objects is a little node on this. that has to get mapped through that mechanical discipline and then eventually merged into what is the core of this little donutty thing I put together called the federated model. So that concept is incredibly important, and there's really no amazing technology solution for this. It's just the process of working together to build a cohesive kind of combined model of the building. Final step is to make that federated model usable and viewable in a lightweight mode. And so I'm actually going to start with the analogy down here, because this helped me wrap my head around this process early on. So when we're drafting a document, we start in Microsoft Word, and there's a lot of information in that Word document, a lot of ability to manipulate the look in the actual content, right, in that document. We then lighten up that document by publishing a PDF. We then open that PDF into a reader like Acrobat Reader, right? That same process applies to the 3D geometry that you use in a digital twin platform. So the authoring tool, for example, Revit, but there are actually many authoring tools, but I'm going to stick to kind of the Autodesk family here for today. The Revit platform is used to actually create and kind of modify these objects. Most importantly, you also apply properties about the objects within the model element itself, and you generate what's called a Revit ID, a unique identifier that says this pump is kind of known in this Revit model with this unique identifier. You can then essentially publish what's called a Navisworks file. This is a lightened view of that Revit model. You can do this in chunks, meaning you can split out maybe floors or systems so that you have the ability to load in a lightweight version of what can be a pretty massive authored model in the Revit format. So Navisworks is, again, just an example of a tool that helps you apply some bulk changes to the textures, the colors. It helps you create what are called saved viewpoints, which can be like slices or filtered views of that model. And again, this allows us to view this information in a web browser instead of running some massive computer with Revit, right? So this process of lightening the model is critical to how your digital twin actually performs when you open it up, right? The last process is to just load that into a viewer. So Autodesk Forge is a pretty common one. The viewer does not really manipulate any of the objects from the model itself. It simply allows you to navigate the model, apply some visual settings, like you can change the background color if you like. You can filter objects, you can search objects, right? The viewer is just your way of interacting with this lightened model. This is an important concept. Again, if you don't do this, your digital twin platform is not going to be something you can interact with. So it's a pretty important process to go through. And the last point I want to make is that even though James had the definition of 3D geometry as part of the digital twin, it's important to think of this just more generically as spatial data, right? If you have applications that require 2D, such as like wayfinding or heat map visualizations that you want to do, 2D is still a great format for consuming that information. What's important to understand is that these aren't separate models. It's not like you have two sets of spatial information. Your 2D view should simply be a top horizontal section, right, of the 3D corresponding floor plate. If you set it up this way, you are only editing one thing. You don't need to have two separate versions for 2D applications versus 3D applications. It's just one cohesive model. I'm going to go back to this slide for a second and answer what is definitely the most common question we get as a digital twin platform. What if I move something in here? What if I want to update my floor plan, right? That's a really common use case, and it's a challenging one to manage, frankly. The answer lies in this important purple text here, these IDs. So if you have an object in the 3D model, it will forever know that, like, if I'm a pump, I have this Revit ID all the way back to my authoring tool. If for some reason I need to move that object in space, maybe I'm doing a tenant fit out and I'm moving walls, I'm relocating assets, I can move an object and maintain its ID, and I won't lose track of all these connections I'm making, all these modifications I'm applying to get that into my digital twin. So the process of modifying your spatial environment goes all the way back to this authoring tool. You move that wall, relocate that pump, you keep that ID, you republish to your lightened view, and then you republish to your viewer, and all the connections should be maintained. If you create a new asset, like maybe I'm removing a pump and replacing it with a different type of pump, you have to kind of recreate those connections. It becomes a new asset in your digital twin. That old asset needs to be archived and kind of, tracked in a different way. So that's the process of shifting things around. It's not, frankly, it's not like an easy thing to do directly in your digital twin platform. It requires this kind of knowledge of this authoring, lightning, and then viewer, the steps you took to get there. And you have to kind of just essentially recreate those, tweak that authoring tool, republish it to your viewer, and you'll see that change in your digital twin environment. Moving quick here. So that's the federated model concept. That's how we get this beautiful 3D geometry. The next step is to have a kind of a backbone that defines what each asset is in that spatial environment. So an asset register is the term I use for this, an asset being, again, like a mechanical asset, like a VAV, but also an asset doesn't have to have live data associated with it, obviously. An asset could be a door, a carpet tile. How far you take that definition of what an asset is kind of up to you. And that's really the first step in building an asset register for your digital twin. You need to define your asset classes. If I'm really interested in knowing what every single carpet tile color and who made the carpet tile and where it's located, then a carpet tile becomes an asset. If I don't care about that, then you don't need to define properties for the carpet. It can just be a texture in your 3D model. So there's this kind of balancing act between what's useful in the digital twin. It needs to be an intelligent asset that you can apply properties to. And then you need to take it to the next step and say, well, how many properties do I want to apply to my asset? This view that you see here is an example from a project we did where we're trying to set the kind of gold standard, if you will, for what, in this case, a VAV box is, or a constant air volume box is. And so all the fields you see here on the left are just kind of static properties of the VAV. These fields that are specific to the VAV itself, like the CFM range, that wouldn't apply to other types of assets. And then, of course, you have documents that you want to live in the digital twin as well. So spec sheets, O&M manuals, etc. So again, not a technology really solution here, just more of a process to set standards on what an asset is. How you populate those fields is kind of the big question. And so back to this idea of the authoring tool like Revit, if you've created an asset in that authoring tool, it has the ability to apply properties to it directly in the authoring tool itself. And so you can actually query these properties out via API, via direct export, however you like to do it. And this kind of forms the starting point for how you build out your asset register. You can actually query that federated model that you built and at least get to the point where I can say, hey, I have these disciplines like mechanical, electrical, etc. I have these systems like airside mechanical. I have equipment types and equipment markers, as they're referred to in Revit. And obviously I have a lot of spatial context, like where it's located and to an extent what it serves. It's a little more complicated, but you can just, in a perfect world, if you've applied all these properties, if you got ahead of the design process and made each discipline populate these in a uniform format and everything worked out great, export, boom, 50% of your asset register just got populated directly from the authoring tool. You can probably tell by how I'm talking to this, that never actually happens. So there's always a bit of gap filling. Another thing to just point out is that there's typically if it's new construction, there will be a construction management platform. Procore is an incredibly common one. Usually there's like an asset management platform, whether that's in the CMMS or something else. Obviously, I think everyone on this call can appreciate there's some other place to grab information about assets. We typically look at things like Procore in the new construction process. And this is where you can pull out sequence of operations documents, spec sheets, model files themselves, etc. But really the last step, like the forever step, as I call it here, is to keep going, right? Like the asset register becomes a digital twin. And it's unlikely that you'll ever, even in a brand new building, come out of that with this like 100% green pie. If I've set standards for what my air handling unit fields, what I want to track on that, and I can get 95% of those filled out as we hand over the building, great. If I'm in an existing building, this might take 3 years to populate. And so there's no secret here. I mean, what's unique, I think, is that the digital twin gives you a home and the kind of the final source of truth for what an asset is and what those fields are that you want to track and then maintain over time. And so over the course of operating the building, you can work with FM teams and vendors and whatever to get this pie to, fully green and make sure that all 66,000 assets in this building have 100% compliance. But it's unlikely you get that day one or even day 300, right? It's going to take a lot of time. All right, connecting live data. How am I doing on time? Going as fast as I can. Connecting live data to this federated model now with an asset register. First kind of basic concept is to locate which assets in that federated model are actually associated with a live device. So again, an asset in Revit could be a door. And so there's really no, unless you flagged assets or put certain properties onto that asset to indicate it's a BMS, it'll have a BMS device, for example. There's a bit of work just to find that, hey, this is an air handling unit. And yes, I have a backnet device that controls it, right? And so there's an initial, alignment of assets that have those live devices as step one. Step two is kind of this concept of having this abstraction layer, meaning you're going to have an asset in your digital twin, like an air handling unit, that is actually associated with multiple live devices and also links back to the spatial data that came from the federated model. And so the digital twin is really, I think, the only appropriate use of this global unique identifier. Like, you need to have this final unique ID that can then map one-to-one to the authoring tool, to your lightened view of that geometry, and then whatever live devices are associated with it, like a backnet controller or maybe a Modbus meter. And so this process of creating this abstraction layer and then mapping down to the spatial and live devices is how you then, merge all of that content into one, so that as a user of the digital twin, I click on this AHU4 and this all comes in, right? I don't need to know that some of it's the backnet device, some of it's a metering device, and that there's model files behind it. It just feels like one connected asset to me when I interact with that in the digital twin. And the final step is to, incorporate that live data. So there's some basic concepts that apply, I think, across all digital twin platforms. One is this idea of just searching and filtering assets that have live data to, in a way, kind of see their system connections. So if I'm in a tool like Forge, I can apply kind of bulk filters and queries to essentially see a connected system. So that's just core concept number one. I can also use live data to modify the way that federated model is viewed, with things like color changes and even transparency adjustments. So Autodesk Forge has an open API. You can write to it dynamically in like a real-time environment. So imagine this AHU went into an alert state, right? I have a backnet object saying I'm now a value of 1. It's a fan fault. Maybe I want to write this to a color of red, so I indicate that this thing is now in an alert state. That can be done through some clever API connections to your viewer tool based on the live data that you've connected to the twin. And last but certainly not least, just this idea of having a one-click pull up my trend data interaction. So directly in the digital twin, I can see current conditions, but also whatever, a trailing 7-day view of whatever data is available on that asset. Beyond this, I think it gets really specific to your digital twin platform, but I think these three concepts apply, across the board, or they should apply across the board if you're looking to interact with live data in that digital twin environment. All right, and then last but certainly not least here, James's final definition of the digital twin was this platform for applications, I think you called it. So to me, that means we need to have a data model set up behind this digital twin that allows you to query this information and kind of serve it back up to other applications like fault detection or whatever that might be. And basically that middleware layer with open APIs and the ability to get to that information. So just to level set, there are many, data tagging, data model standards out there. I think the ones that, I focus on that relate the best to a digital twin is this combined haystack and brick definition. So I'm sure most of you are familiar with this, but haystack to me is kind of like your nouns. It defines an asset by its physical properties. So this AHU can be classified as, something that is only cooling. It has a DX cooling coil and a condenser water cooling coil, for example. Brick can give us the verbs that associate this box, this asset, with what it serves and what it's connected to. So this AHU is fed condenser water by some pumps up on the 68th floor. It's fed ventilation air by some heating ventilating units. It's located in level 50, and it supplies air to a tenant, for example. The digital twin obviously I guess I'll say this works well in a digital twin environment for the obvious reason that you have all that spatial context, and some of those relationships can be defined straight from that federated model that we built, right? We'll get into that here in a second. One other just kind of finer point is that when you have these connected assets, those relationships you define directly to the asset can be traversed, and you start to see these transitive relationships be defined, meaning I know this AHU is fed water by these pumps. They go through a heat exchanger. They go through another set of primary pumps up to the tower. Therefore, I know that these towers are connected to this AHU. So it's a powerful concept of the digital twin model. You need to be able to traverse these nodes and know that a space or a piece of equipment is connected to first, second, and third level connections throughout the building, right? This is probably my favorite slide. This craziness that you're looking at now is the back end of Revit. Revit is just a bunch of tables that have relationships defined in them, so that when I click on an asset, it knows to pull in the spatial context, the asset context, whatever it might be, right? And as we connect those assets, we're essentially connecting tables of data behind the scenes in Revit. I'm actually looking at this now. This is just a Power BI report. So you can connect to Revit in many ways. Again, you can export all of these tables into CSV, whatever you like to do. The ones I'm highlighting, I think, are the most relevant for giving you a head start on creating that kind of haystack brick combined data model. So Revit, for example, has the concept of a level, an area, and a room. Rooms are contained within an area, and areas contained within a level, for example. Well, obviously those are vocabulary for now my brick relationships. I know that an asset is contained within a certain area of the building. I know that it feeds air to certain rooms, right? So Revit, just as the authoring tool, aligns very well with some of those brick tagging techniques. Revit also defines a model element. This can be, again, anything in the model, a length of ductwork, a pump, a door, right? But for us, there are certain types of model elements that immediately can become, a haystack equivalent tag set, if that makes sense. So a model element could be a VAV. You could have types of VAVs within your model. So type A might have this size of inlet, this type of reheat. Type B might have a different combination, right? So you can have subtypes or subclasses of your VAV if you follow the brick vernacular. And then you can have an instance of that model element like the individual asset itself, the VAV01. So I think you guys can connect the dots here, but what I'm trying to say is that the authoring tools provide a rich data set for giving you that head start on the data model. Again, if these properties are completed and if you have a model to begin with. So I think we can all appreciate this is completely different in the existing building space, but even in new construction, I like to think of these almost as like, a backnet controller. It gives you a text box and you can put whatever you want into an object name, right? It's not that different here. You can name your levels and areas and rooms however you like. Different disciplines can set up their own naming conventions. That kind of BIM execution plan and the process of guiding all the disciplines to a federated model should get down to this level. Like, how are we naming model elements? What properties are we associating with those? How are we associating those with levels, areas, and rooms? In a perfect world, if that's done correctly, this is a straight export into your amazing brick haystack data model that we all want. Final slide. What is the platform for applications look like then? So this little diagram on the southbound side here at the bottom are your building systems. On the north side is, the cloud. I think we've all probably done a network diagram like this in our careers, but it's really no different for the digital twin. You're connecting directly to these live systems. You can deploy, whatever gateway device or methodology you want to get to those live systems. And as you transform that data and align it to the federated model, like we just talked about, you have this nice clean data set that gives you spatial data. So the actual model elements themselves, the asset information from the asset register, and now you've got telemetry data from each of these live systems. That's a pretty rich data set to serve up to any, smart building application. And so this middleware concept of then opening up an API and feeding things like a CMMS analytics. This is actually a real building example. They had a seismic monitoring thing they were doing, which was cool. And then other map applications, which was kind of a unique one, maybe for like looking at conference room booking systems and other things that need spatial data. Well, they should be consuming that from your digital twin, right? You want one source of truth for all these types of data, spatial, asset, and live, and those can enhance or just feed into these other smart building applications that you might be deploying kind of within or next to your digital twin environment. That's it.
Cool. Thanks, Dennis. I really appreciate it. Yeah, that was super insightful. I think the light bulb moment for me was the concept you said of like, this is the home. This is where all the data lives. It might take a long time to keep it, get it up to date, but this is where everything lives. I'll sort of start with these questions in the chat. If anyone has questions that aren't in the chat, you can raise your hand and I'll call on you. So back to the sort of 1, 2, 3 authoring process, how labor intensive is that, Dennis?
Yeah, that's a good question. I might lean on my Taylor helper here in a second, but from my like layman's perspective of this, because I've never even opened up a Revit model, to be honest with all of you guys. So I'm really channeling my inner Taylor here. But from my layman's perspective, I see the industry basically bringing some of the expertise to do this kind of in-house. So if you're a major REIT or just anyone who owns buildings, manages buildings, you have someone who knows how to get into an authoring tool, whether that's because I have to redo tenant fit outs all the time to help with my leasing process or whatever it may be. So I think a lot more of this can be done with just internal teams, and you can just kind of offer up the tool set and say, have at it. You can go manage this yourself, or it's done kind of through a service or as part of like a SaaS fee. The ongoing management and upkeep of that digital twin should be incorporated into like the platform you're buying to do this, right? Like I kind of see those two options. Taylor, I don't know if you want to add anything to that as far as like, how many button clicks you have to do to move a wall or whatever, but I don't think it's crazy.
Yeah, no, you're spot on. And I think the tools that you've outlined here are tools that are already part of the process for designing, procuring, and constructing a building. So the goal on any of these projects is to get involved with the design teams early enough so that, these requirements are part of what they're doing in Revit as they're creating the documents for these buildings to be built. It moves into a kind of Navisworks environment where a construction team may be doing clash detection or quantity takeoffs, things that are already part of their scope and their tool set. And then the information just kind of moves along the timeline into the digital twin. So in terms of like additional requirements, there may be some additional data entry, some, additional detail in terms of parameters that we want filled out for certain assets. But in general, the goal is to align with the design and construction process that's in place and augment, a little bit or nudge in a new direction where necessary.
Cool. Yeah. And I think that answers Omar's question. I think that also answers John Mackey's question from the breakout rooms. It sounds like there's a bunch of different ways to keep it updated through the owner doing it themselves or them providing some sort of, or somebody providing some sort of service to keep it updated, or have it be part of some sort of SaaS model, right? Where the software vendor keeps it updated themselves.
Hey, James.
So yeah, go ahead.
I wonder if I could jump in on that a minute. I mean, so realistically, the level of 3D detail that you're showing here is only possible with a new construction building that has BIM data. And that's a small percentage of the building stock. So for existing buildings, we're never going to get that level of detail. And I don't think anyone's going to ever build that right retrospectively. So this is what you're showing here, at least on the BIM model piece, is probably only realistic for moving forward, correct?
I mean, Taylor, you can jump in here too, but I mean, first of all, I think the quality of your spatial data is up to you. I mean, down to this idea of just having some basic 2D geometry with an intelligent square on it that says I'm an AHU can be a digital twin. And this is where we get into the gray area of like, what is your digital twin, right? Like that's not something any digital twin software company should dictate. It's just, you need to understand that, like, to me, the minimum definition is you have intelligent objects that you can align in within their spatial context. And whether you do that 2D or 3D, the number of objects you actually track in that environment is up to you. I don't have carpet tiles in this view. I don't have anything other than an AHU with some connected ductwork, right? That might have been my requirement to just manage my base building systems that I'm responsible for as the owner of this property, right? So I think that's one of the answers. And it's very, very easy to get, even from like a, I don't know, like a PDF floor plan set to this level of quality in a matter of days. Like, this is not rocket science to go trace some things and map some objects onto it and get them like intelligent, right? I also think what's interesting to look at are like the innovations coming out of like the scanning of buildings and all the options you have for collecting this information after the fact at a price point that is just coming down and down and down and down every single day. So I'm not an expert on this, but you hear those like promises of I can, you know, walk around with basically a camera on a helmet and scan your whole building in a day, right? Now, what does that give you is another question, but there's definitely options for getting an existing building to a level of a digital twin. It just comes down to like, what end of the spectrum do you want to land on? What is your minimum definition of like a quality digital twin?
Yeah, Omar is raising his hand. Go ahead, Omar.
Yep. Yeah, thanks, Dennis. That was awesome. So maybe building on a previous point. So if you have an existing building and you're building a digital twin, as you said, that's very simple and it's just this intelligent object here. What would be the difference between that and like just your regular building automation system with graphics? Is that considered a digital twin? I
mean, by my definition, I think it could be. Where I draw the line is like the BMS graphics are images, PNG images, right? Like whatever they've uploaded, they require, so like that same challenge of like, well, what happens if something changes in my building? The answer is a lot different when your base geometry, your base spatial data is locked away as a flattened image. You're basically saying, I'm going to go delete this and start over as the answer to the question we had earlier around like, well, what if I move something, right? So to me, it's about like, if you want to maintain a digital twin environment and you want to keep this spatial data up to date, you have a use case for that, then you need to migrate that into an intelligent authoring tool, whatever that might be, right? So that to me is the big difference. We're talking about images versus objects that can be moved and modified and associated with properties that help you link them back to live data, everything else. So that's kind of the difference between just a flattened image and an intelligent object, right? Like that's the line I draw between the two.
All right. So there are lots of amazing questions coming in. I think maybe I'll send them to you, Dennis, and let you sort of send them out. And I'll put them, when I send out the recording, I'll send out your answers with it as well. But this has been awesome.